Yep. All right, so we're going to talk about Ruby on Rails. This quarter, we're going to use Ruby 2.0 and Rails 4. And so we're going to go through some of the theory on Rails first a little bit. So we're going to go through a quick introduction, history of Rails, some of the popular websites that are using Rails, what a server actually is, browsers and how they get requests from a server and what that looks like, and then talk about the model view controller paradigm. That's what Rails uses. Model view controller, it's a way of structuring your programs, is all that is. It is similar to the .NET, yes. Similar. They took it from Rails. Rails, let's talk about Rails, we call it a full stack web server. It's a development platform to create dynamically driven database-driven dynamic websites. Boy, you got to put those words in some order there. That means that we can pull from a database of, say, videos that we have and display them in some order on the browser. And we can do purchasing and shopping carts and blogs and anything you can think of that saves information in a database. So this is taking the static websites that you're used to and breaking them up and creating full-on web applications. So we call it a full stack. Well, we can get that in a minute. The Rails is simply a Ruby gem. It's a huge, humongous Ruby gem, but it's a gem nonetheless. And it's a gem that includes 20 or 30 other gems. So it's all written in Ruby. If you can actually go look at the source code of Rails and see Ruby code in there. It's all Ruby code. So because of that, and because of the Ruby language being interpreted, it can run on any platform. I can run the same Rails application on a Mac or a PC or a Linux box. And in fact, when you send me your projects, I usually run them on my Mac because they're easier to run. So, and I don't have to do anything to your code. I can just run it right away. It's really good. And that's because of the Ruby language itself. It's a full stack, meaning that it deals with everything from getting a request from a browser, processing that request, going out to a database, potentially getting data from a database, rendering that all into what? What does a browser see? HTML. That's it. The output of a Rails program is all HTML. Right? So anything we can put on HTML in a static page, we can output from a Rails server. So what other things are in a HTML page? CSS. Okay, so CSS, the styling is served by the Rails server. Okay, what else? Your JavaScript. Okay, so I can serve JavaScript to the web page. And where does that JavaScript run? On the client. It's a client side, runs on the browser itself. It has nothing to do with the Rails server. Images, Flash objects, anything like that that I can serve on a static page, I can serve through my Rails server as well. All right? So that's why it's called a full stack. It deals with everything from start to finish of getting a request and satisfying that request back to the browser. Rails uses convention over configuration. You don't see a lot of configuration files, whereas if you were doing Java servlet pages, which we don't teach anymore, they have tons of these little configuration files. In Android development, you're going to see tons of these configuration files that try to define things for you. We still use the concept of dry, which is don't repeat yourself. That's a concept in Ruby. If we're repeating ourselves, what should we do with the code? Put it in a method. That's right. Put it in a method. All right. It's fully integrated. There's no other adapters needed. The idea is that you learn one, you're going to learn them all. These are some of their keywords. We have some gems that we use, action view, action controller, which we'll talk about as we get into those. Those are all created through Ruby gems. So this is what it does. It accepts requests, processes the request, accesses databases, manages files, stores information, handles errors, etc. That's called a full stack web server.
So which part is the M and which part is the V and which part is the C?
So the model is, which we'll get to, the model is everything dealing with the database. Everything we store permanently inside of a database is considered the model. The view is everything that we render back out to the client as HTML. That's what handles the view. The controller is kind of the brains of the situation, where it accepts a request, decides whether or not it needs to go to the model to get some data, and then sends all of that data that it's collected to the view to present it back to the browser. So we have some nice little graphics that show that. So a lot of times you see in job postings that they want a full stack developer. A full stack developer is somebody that can do design, style, markup, they can code, they can manage hardware and operating systems, and deal with databases. They can deal with it all. And so anything, rather than just coding one little thing, they can deal with how that works on the operating system. They can install an Apache server on Linux. They can do source control. So that's what we try to build here at our 2-year degree, is a full stack developer, somebody that can do everything as much as possible. And in our 4-year degree, that would really be the case. You'd be very much a full stack developer. All right, let's talk about the history. It was developed by a single person, David Hannemeyer Hansen. He's from Sweden, I think. And he created it because he was writing his own code for this company called 37 Signals. And he originally wrote it for a project called Basecamp, which is still around. If you go to basecamphq.com. Well, it took me back to Basecamp. They must have got that. This is a project management website that lets you set up a project and have multiple people access it. You can set up due dates and things like this. This is all written in Rails. And he wrote that because he liked the Ruby language itself. So he said, well, I can do all this in Ruby. So he started developing his own little server, and he liked the way that Ruby fit together. And he used the paradigm of the model view controller, and he built this site. He didn't intend to build Rails when he started out. But so many people liked it, and he went to a Ruby conference and showed off what he did as Basecamp, and everybody was excited. So he extracted the code that created the Rails environment into a gem. And it grew from there. It was in 2005 that it was first created. So it's fairly young compared to other systems. I mean, and here he's born in 79, which makes him really young as far as I'm concerned. So he made it open source, which was a good idea because other people then started working on it. And it grew from there. It's becoming very popular. All right. So what are some sites that use Rails? Anybody know? Boot Camp, okay. Canvas is all written in Rails, by the way. Good. Twitter was the big use of Rails, but they decided recently to go a different way, and they're not using Rails right now. They still use Rails on some internal projects, but not for their main Twitter feeds. No, nobody uses ASP. Are you kidding? ASP is used on a very small number of sites. Microsoft, but not all of Microsoft, because I built them a website that did not run on Microsoft for their Mac stuff, so they're not all ASP. So some of these, Hulu is one. GitHub, which I've exposed you to if you took my mobile class last quarter. Groupon, Yellow Pages, the Urban Dictionary. Those are all Rails projects. Pardon me? Living Social, yep. Probably 90% of all startups now use Rails because of its fast, agile methodology. We can create things so quickly in Rails and get it up and looking good, which for startups is important to get the next level of funding. They have to show that they have something working. In the dot-com days, in the 2000 time frame, I was really busy. I couldn't charge enough to stay unbusy. I mean, at one point I was charging $2,000 a day to work on websites. On-site. They wanted me on-site, so I'd have to fly. So they'd pay for all my expenses, food, travel, lodging, and $2,000 a day to get a site up that made it look like they were a business. Then they take that and they go public and they make all their money and they don't care about the business model sustaining itself. So you have all these sites like pets.com that was huge, gone. Grocery.com, gone. They might be back again, but at the time they were hundreds of websites going public just based on the fact that they had a website. It was pitiful. They had no business model behind it sustaining themselves. They didn't think about whether they'd actually make money. They talked about burn rate of cash. So they got venture capital money, and the big words around were how fast were you burning your money? Burn rate. It's really sad. Anyway, those were the good old days. The late 90s, yep. All right, so let's talk about what is a server. Any questions before we get on to there? Questions? All right, what is a server? So a server is just a program running on a computer. It's listening on a TCP IP channel on a port that's typically port 80. It reads in those commands. It accepts incoming requests. It does something with that and outputs some HTML. It's all a text-based command structure in a protocol called HTTP. That's the protocol, Hypertext Transport Protocol, built back in the early 90s, and I can never remember his name, from CERN, Switzerland. He built it originally to tie academic papers together, so that when you clicked on a link here, it took you to another academic paper. That was the original reason for the web. Anyway, it's a very simple server. You can build a server in Ruby in about 20 lines of code. It's really simple. So we will be running a server on your local computer and servicing your requests from your browser locally. All right? It uses port 3000 as a default, as opposed to most websites use what port? 80, okay? If I don't put a port number on my browser, typically it's going to go to port 80. If I put :80 here, that says go to port 80. Well, and why doesn't it work? That's interesting. Anybody know? Right, because it's HTTPS. HTTPS is actually port 443, and that one works. So I can put a port number at the end of the domain before anything else, all right? That tells me to go to a specific port. It's like a socket on the computer. You're plugging into this, and if you remember back to your networking for developers class, that's what that is. All right, so why doesn't it use port 80 on our local machine? No. Well, if somebody requested a site to your computer, that's possible. But they can still do it to port 3000. As you'll see, as we set up servers in here, you can make a web request to another student's Rails server.
It has something to do with 1024.
Yes, it does. Very good. You're right on the right track. So ports that are below 1024, the number is below 1024, are considered reserved ports, and they're reserved by administrative rights. So you typically have to have administrative rights on the computer to use port 80. So they chose port 3000. It's an unused port above the 1024. I don't have to have admin rights on the computer, and I can test my Rails software locally. All right, so that's it. There you go. All ports below 1024 are normally protected, require administrative access to open. All right, wow. I know this is dry stuff. We'll get into real fun stuff here in a minute. Browsers and REST protocol. Browsers use the HTTP protocol, which we talked about, Hypertext Transfer Protocol, to send and receive requests over this port. So it's either port 3000 or port 80. I send a little request over this port. The server responds. It sends me back some HTML. They respond, and HTTP is a stateless protocol. That means that when I send a request out to the server does stuff and sends me back something. That state is closed. The server no longer knows about me, and the browser has cut off the connection. So if I want to go get something else, the next page, I have to make another request back out to the server. The server solves that one single request, comes back, closes the port. So there's no way to manage that, or the server to know who you are because it's cut off the connection. Every request is considered new. So that's why they call it stateless. The server does not know who you are. I can't keep track of your state based on this open and closing connections. So how does a server and a browser communicate and know who you are from page to page? Not from the IP address, from the cookies, okay? So the server can send back in the first initial request a cookie. The browser holds that, and every subsequent request, it sends the cookie that it just got along with the request for more information. The server says, oh, you're this cookie that I just sent. I know who you are. I can keep your name on the browser. So things like if I go to Google, it knows that I'm Dave when I click on another link. It keeps track of that. Every link that I click, a cookie is being sent back to the browser to let them know who I am. So that's how state is maintained through the text protocol itself, not anything else. Right? So HTTP is simple text-based. The errors come back in the text response. And the response contains a header and a body, which you'll become familiar with here. So let's do that if I can get this in. Let's open up the developer tools, and under network, I'll go to just google.com. And you can see all these requests that were sent to the server from the browser. So these are requests, and I initially typed google.com into the browser. So the browser said, okay, I'm going to go out to Google, and I'm going to get, using this verb, there are 4 verbs that are used. They're trying to add another one. 4 verbs that are used to communicate back and forth between the browser and the server. So it's going to get that request, and what gets back is it sent back a 301 error code. It says, I don't know what that is, so I'm going to do this error code. So anybody know what a 301 is? No? Yes, you should learn how to Google. A 301 is a redirect. It says, the server doesn't know where that is, but here's an alternate address where you can go to get the information. So it sends back a redirect and tells the browser to go to www.google.com. All right, so it redirected. So if I type that up here, again, I go to google.com. By default, since I didn't put HTTPS, it's considering this as HTTP. It's non-secure, right? But look at the address. Without me doing anything, the address changes to HTTPS and the www. So it had to do 2 redirects to get me to that. So the first one is it redirected me to www, and then it redirected me to the HTTPS. So it did 2 redirects to get me to the front page. Then it says, okay, the HTML that came back has more information in it, like CSS files and JavaScript files and images. So the browser has to parse through that HTML and make additional requests for every single element on the page. So you see it went out and got this photo.jpg, which is me, and it's not even on the page, is it? Here it is. It went and got this photo, which is this little guy here. It went and got this logo 4w.ping, which is the Google here. It goes down. It gets more pings, some JavaScript stuff, and it got the photo again, which I don't understand why it got different levels of photos. Those are still interesting. Yeah. So the next code, when it finds it, it returns a code of 200 and OK. So let's look at yes, that's one way. So these are the cookies that Google sent me to maintain the state across the browser connection. So it's a bunch of garbage that it sends to you. There's session IDs and different things that they use to track that this is me, this is the same person making the next request. Let's see, there was another. Just a minute, let me. So if I look at a request that matched, so here's one. This is the text that it sent back to me, all the HTML that defines this Google page. Most of it is JavaScript, compressed and garbage-fied, uglified, so that it's hard to read. But that's the actual text that came back. The browser sees that and renders this page for you to look at, right? Everybody should know HTML and all that stuff, right? But the headers are important. This is what gets sent and what gets returned. The request headers, this is what the browser sent. I can't make that any bigger. This is what the browser sent to Google's server. The response headers are what Google's server sent back to me. So this is information. It says this is the protocol. It's using 443. That means it's using HTTPS. It tells you the date that this page was generated. Gives you the status. This is the error code. So all of this is coming back as just text as part of the server. All right? And when I get the information, I'm using the verb. This is what I'm sending to the browser. To the server from the browser. I'm going to get the slash, which means get me the top level page. I'm going to use HTTPS. I'm going to use this version of the HTTP protocol. These are the types of information that I will accept back. So I'll take back text HTML, these different versions, application/XML. And here's the cookie that I'm sending Google so it knows who I am. So the browser itself sends back the cookie every request. So if I make a request for an image, it sends back the cookie. CSS sends back the cookie. So that's one way. We'll get into more of that as we get into Rails. But it's important to know how the requests come and go from the browser. All right? So this is the typical request. You can look at that. It's online. This is a response. So a 302 is a redirect as well. And it tells you what you got is not here, but here's where the new URL is. So it did a redirect and redirected me back to the secure version at tripledove.google.com. It also tells you what server it is. So let's do that. Let's go to Microsoft, and let's look at its requests. So they did a redirect as well. Notice that. So let's finally get to the page. Here's the headers, and the response headers tell us what server it's running. They're running IIS 8.0, surprisingly. Isn't that amazing? If we go to Hulu, I can look at Hulu's. After all the redirection, we actually get a page. Let's look at this guy. And the server is Nginx, which is a Linux-based server running in front of the Rails application. They do that because these servers are optimized to send images faster than Rails can. So in a high traffic site, they put another server in front of that Rails just to handle images and static assets. Right? Any questions on that? Isn't that cool?
Who's written in Rails?
Hulu?
So they need 2 servers to run their site?
Yeah, at least. Very likely they have 30 or 40 because...
No, I mean 2 for each request.
Not typically a one-to-one, but yes.
That's definitely an upside. Right?
No, because Rails is free, Nginx is free, Linux is free. All they have to pay for is the hardware. Right. All they have to pay for is the hardware. Whereas if I have IIS, what do I have to pay for? I have to pay for the OS and a server configuration, which is, thousands of dollars, and a hardware, which wastes a lot of the hardware just to run the OS in the first place, and it's just not efficient. All right, so here's the REST protocol. REST stands for Representational State Transfer, which is a lot of garbage. Here it is, Representational State Transfer. But basically, it has these 4 verbs that I use to request information from the server. A GET request is getting information from the server. A POST is where I'm sending information, usually as a result of filling out a form. So you fill out a form in HTML, you hit submit, that data gets posted using the POST verb to the backend server, and it does something with it. A put and a delete are not yet implemented by the browsers. But the guy that did Rails was so hard over about using that he's pushing the browsers to use these verbs so that it makes the interaction between the browser and the server more cleaner. All right. So they fake a put and a delete by changing some values in the posting. So you'll see that as we come through there. All right. So I said that, not implemented. So this is, and maybe we should come back to this, the routes. We talked about the model view controller a little bit, separation of the view and the business logic. That maps to the CRUD. You know what CRUD stands for, right? Create, read, update, delete on a table in a database. So this routing lets me have 7 different ways of accessing data in the database. So the first one is list me all of the products in your database. That says give me an index. And that uses the get method. This one says show me the product that has an ID of 2. That's what the URL looks like. And it uses a get as well. If I want to create a new one, I need to first tell the server I'm going to create a new one. It comes back and sends me a form to let me type in the data for that new product. And then it's going to use this URL, products, with a post. We're going to post that form back to the server. Then if we want to edit it, we say, I want to edit product whose ID is number 2, and I want to use this edit word, and that's a get as well, using those verbs. If I want to update, that's a result of pressing submit after you update the form on the screen, which you'll see as we get to this. That's a put, but the browsers don't use that, so it uses a post instead. And then to destroy, that's the D part of the CRUD. I can delete using this delete verb, which is also not used. But so those 4 CRUD actions result in 7 actions in a RESTful route. That's what that is supposed to say. A lot of stuff. You'll be inundated in this very shortly, so don't worry about it. So this is a quick graphic that's from your book. You make a request from a browser. It goes to the main controller in Rails. The controller is a piece of Ruby code that says, oh, I got a request. I'm going to look at what the request does, and I'm going to do something with it. If the request requires me to go to the model, I'm going to go out to the model, which queries the database, gives me back the result terms back to the controller, and the controller then takes all of that data, the query and everything that it got, sends it off to the view, and the view is what assembles it all together, creates the HTML, lists out all the products, and ships it back to the browser. All right? So who in here has had PHP already? Yeah. So you that have had PHP, you're going to love Rails. Those that are in PHP, you're going to learn to hate PHP as you work with Rails, because you're in it at the same time, right? But you'll see how tedious PHP is compared to Rails. All right, so let's get started. We have a couple minutes. We're going to create a new Rails application. So first of all, we're going to do this in the command line to start with before we get to RubyMine. After this, we'll do most things in RubyMine just to show you other ways to do that. Let me fix this up. All right, so from a DOS command line, I'll probably switch back and forth between RubyMine and DOS. Most of the tutorials that you see on Rails use the command line to do everything. I don't know why, but they do. So from a directory on your computer, we're going to, first of all, we have to make sure that Rails is installed. So let's start with checking our Ruby version. We can say Ruby -v tells us what version of Ruby we have installed. So you should have 2.0 point something. Then we can say, let's look at Rails, the version of Rails, Rails -v. And I have Rails 4.0 installed. You guys should also, right? At home, if you haven't installed it, to install it, how did we install a gem? Like the, there you go, gem install Rails. All right, if I do that, it's going to go out and find the most recent version of Rails. But I can also say I want a version that's 3.2.8. I can go backwards in time if I want. All right, so Rails is already installed. Gem is a program that we're going to use a lot. We look at the version of Gem that we have. You should have 2.03 or higher. Bundle is another program we're going to use, and we need to make sure we have the good version of that. So we might be updating that over the course of the quarter. Rails changes constantly because it's open source, so they come out with new versions all the time. All right. So from here, let's say I want to create a new project. So I'm going to use the word Rails. That's my program name. And I want my project to be called whatever, right? I don't know what. Blog. All right? Sorry. I need the word new. Rails new blog. And that will create a new Rails project and generate some code automatically for me to do a lot of stuff. All right? So when I do that, it creates a new, oh, I already had one. Let's not do that then. A Rails new Dave blog. How about that? All right, so it creates all of these files. It creates a directory called DaveBlog on my disk from that location. All right, it should finish and show that you have the bundle installed and everything is done. Notice all of these gems that it's using. It went out and found active support and Builder and Rack and Mail, and all of these things are being used by Rails. So there's a lot of other gems that it goes out and finds. So let's change directory into the name of the project that you just created. So cd space DaveBlog. And this is all of the files that it created. It created a bunch of files, some directories, everything else which you'll get to know as we work through the quarter. But let's just start the server. We have to remember we're going to work on a local server, and we have to start that so that we can access that server. Okay? So to start the server, I'm going to say Rails space server. Or as a shortcut, I can say Rails space S. S stands for server, right? Very good. You guys are sharp. All right, so when I run that, it should now execute the Ruby code that the Rails has. It starts up this server called WebRick, which is built in Ruby. It's a web server built in Ruby. It actually listens. It's listening now on port 3000 for incoming requests. So let's leave this off to the side here and open our browser. And if you look, let's get rid of the. No, let's leave that on. Okay. So it tells you where it's listening on. It says started Rails 4 in development mode on this address, http://0.0.0.0:3000, which is the same thing as localhost. So I can say go to localhost :3000. I want to go to specifically that port. Come on. Here at the school, we have a problem with Chrome. So I'm going to have to go to the settings, advanced settings, network, change proxy settings. And how did I do this last year? Was it LAN settings? Don't use a proxy for your LAN, all right? So don't use a proxy for this. Let's see if that works. Come on. There we go. There we go. All right. So here locally, you won't have to do that at home. That's a school problem. But you notice that the server over here has a log that it keeps track of every request that came in. So it said, okay, somebody tried to get / the top level of the site, and it's going to process it by going through these different files. And we'll get to know more of that later as it comes up. So this is the page that you should see if your Rails server is running correctly. Then I want you to click on this About Your Application Environment, and that should come up and tell you all about your local environment. Tells you the Ruby version we're running, tells you the gem version, the Rails version, JavaScript, Active Record, all this kind of stuff, and the database that we're using also should be set to SQLite 3. All right. One thing about Rails is that we very rarely now ever have to write a SQL statement. Isn't that great? Don't have to write SQL anymore. It does it for you, and it does it based on what database you have in the back end. So I write all my code the same. I can swap out the database underneath Rails without too much trouble. I can switch to MySQL, add MySQL, and my code doesn't change at all. I can swap in SQL Server 2010 on Microsoft. I don't know why I would ever want that, but I put that in there, and I don't have to change my code. The code has a layer between the requests to the database and actually creating the SQL statements. So I don't have to worry about that. It's very nice. So we're going to use SQLite 3. It's a very lightweight database used for development purposes. It's a single file system. It would never work for a website. I mean, it's going to be too slow for multi-users and things like that. But for development, it's perfect. We just want a quick way. I don't have to worry about users and access rights and all that kind of stuff. I just have a flat database. All right, so if that worked, then you have Rails up and running. That is all good. Tomorrow we'll do it the same, but we'll do it inside of RubyMine. Because if you noticed, there are 30 or 40 files that it created inside of all these directories, and it's difficult to track without using some IDE, in my opinion. So I like RubyMine for that case. So to stop our server, how do you think we stop our server? Anybody know? Nope. Control C, there you go. Control C, hold the control key down, hit C. It says exiting, you want to terminate, yes. And now my server is now stopped. And if I try to reload this page, I'll get a timeout. I can't find anything there. All right?
You did mean localhost 3000.org.
Yeah, right. Yeah, they think. I wonder if that's a real site. That might be. Oh, look at that. That's pretty slick. Somebody chose that because you can get to it by missing the colon. Wow. Nice. All right, any questions on any of that? So the rest of that, we did that installation. I talked about that. We'll go through the rest of this tomorrow, actually creating a controller and watching the request come through all the way through to the view. All right? All right. No questions. Stop.